Hey everyone, welcome back. So in this video I'm going to follow up on our discussion from the last video on production functions and derive the production possibility frontier for a really simple two-output economy. So if you haven't watched the video on production functions, make sure that you go back and watch that before you watch this video. So I'm going to assume that there's this economy out there and they only produce two things, and those two things are memes and fail videos. Memes and fail videos. Okay, so I'm also going to assume that there's only one thing that goes into making both of these goods, and that is labor hours. So I'm going to say that the amount of labor hours that go into making memes, I'm going to denote LM, and the amount of labor hours that go into making fail videos, I'm going to denote LF. Okay, just the number of hours. And I'm going to assume that there's only a certain number of labor hours that the economy can employ. And I'm just going to call that number of hours L. So I'm going to say that all resources are used in either meme production or fail videos, so that the total amount of labor equals L. Okay? So this is the total amount of labor in the economy, total number of hours. That can be employed in either fail video production or meme production. Okay? So, furthermore, I'm going to make the same assumptions about the production function as I did in the previous video, and that is that both meme production and fail video production are characterized by diminishing marginal returns. So what that means is that if you're thinking about the relationship between labor inputs in meme production and the output the meme output, you have a production function that looks like this, right? And it's the same thing for fail videos. So we have fail video output, number of labor hours used in fail video production, and the production function looks something like this. Okay. Okay. So how do we use this to come up with a PPF? Okay. So the first thing we need to do is formulate what we call a four-quadrant diagram that shows all of our inputs and outputs of interest. So up here in this first quadrant, we're going to have the quantity of each of the goods. Okay, so again, we're going to have memes and fail videos. Okay, so these are our quantities. So number of fail videos and the quantity number of memes. Okay, so what else do we have that has the quantity of memes and quantity of fail videos on the vertical axis? Well, we have these production functions. So what I'm going to do is say that on this axis, we're going to have the number of labor hours used in the production of fail videos, and it's going to be increasing as you go down this axis, right? So we're going to say this is the positive direction. Okay, we're used to thinking about this as being the negative direction, but I'm going to say that as you go down towards the bottom of the screen, you have a larger number of more hours being employed in fail video production. Now, we're going to do the same thing Same thing over here. We're used to thinking about this direction as being negative numbers in the number line, but we're going to say this is positive. Okay, so we're increasing in both directions, and this is going to be the number of labor hours used in mean production. Okay. Now, what do we know? We know the relationship between the quantity of memes and the number of labor hours employed in mean production, and since this is increasing in both directions, we're just going to translate this production function over here. So we're going to have a production function that looks like that. Okay. So the same thing goes for the production and fail videos. Since we're increasing the number of labor inputs this way, and we have quantity on this axis, then we're going to have a production function that looks something like this. Okay? Both characterized by diminishing marginal returns. Okay, so what about the labor inputs, right? How can we divide these labor inputs between the production of each good? So we could say that if all labor inputs were employed in mean production, then we would have L labor hours being used in producing memes, and 0 labor hours being used in producing fail videos. And on the other hand, if we employed all the labor hours in fail video production, then we'd have L hours being employed in fail videos and 0 hours being employed in mean production. And we can have any combination between the two. Okay? We could, for instance, have just a few hours in fail video production and a lot of hours in mean production, and so on. So it could be anywhere on this line, right? But we only have L hours to work with. Okay? So what we want to do is say, suppose that we employed any combination of labor hours in both fail video and mean production. How many outputs or units of each fail videos and memes could we produce? So let's just take some point in the middle here, okay? And we'll say that this corresponds to this level of labor hours used in fail videos, and this point here corresponds to the amount of hours being used in meme production. Okay? So if we want to know how much of each good that we can produce given these this quantity of labor inputs, then we just see where this intersects the production function. Right? The production function tells us how much we can produce given a unit of input. So we can just trace this up here to the production function, and the same thing down here with fail videos. Okay. Okay. So we have these two quantities. So the combination of fail videos and memes that you can produce, if we're using all of our labor inputs, meaning that there's no idle labor, then we're going to be at this point right here. Okay? And we can keep doing that for other combinations of labor inputs. So here we have more labor being used in fail videos, but less in meme production. Right? So we can trace out how much of each good we can produce if we're using that combination of labor. So we have this. We have this many fail videos being produced, right? And we have this many memes being produced. So again, we can see where that intersects. And we could just keep doing that. So for every possible combination of labor being used in the production of each good. Okay? And what you're going to see is that as you keep doing this, as you trace out all the possible combinations of labor inputs that are that still maintain this total number of labor hours employed, then you're going to get this production possibilities frontier. Okay, So you're going to get some kind of curve that looks something like this, okay? And we'll extend down that way. So hopefully that makes sense. This is all because of the amount of labor that we have to employ in both of in the production of each good, and because of the shape of these production functions, right? So I could ask you, what would happen if we increased the supply of labor that could be employed in this economy? If we increased L, well, what would happen is that you increase the amount of labor that can be employed in each industry. So I'll say that we have a new line representing all combinations of labor inputs. And what that would do is that it would shift out all of these points, right? So now you have more labor being employed if you maintain the same amount of more labor being employed in mean production if you have the same amount of labor being employed in fail video production. So I would invite you to trace out this PPF using either either an increase or decrease in supply of labor, but as we've discussed before, this increase in the supply of resources available is going to shift out this PPF this way. Okay, when we have an increase in the supply of labor. All right. Hopefully that helps give you some understanding of where the PPF comes from, and we can talk more about this in class. See you then.